to introduce our guest, Bitmovin. So I'm Stefan from CrateDB. Just as a short intro, CrateDB is a distributed database that offers a real-time unified data layer for analytics, search, and AI. So just in a few words, what it means is that you can store any type of data, whether it's structured data, semi-structured data, unstructured data, and put it into CrateDB with very high ingest rates, with a very low latency to index all types of fields that you are ingesting, and also very fast query performance. All of that with SQL. That being said, today we are going to talk about some very interesting use case, which is user behavior analytics and user experience monitoring. And for that, we invited one of our customers, Bitmovin, who is at the forefront of innovation in video analytics. They won over the past few years very interesting rewards. They won an Emmy Award. They have been at the front of innovation. They have been contributing to the MPEG standards. And for that, I'm very excited to welcome Daniel, who is the Chief Architect and Senior Director of Engineering at Bitmovin. And I will let him present his use case. You will see it's very interesting, and feel free to ask any questions. We are here to support. And after that, you can also meet us at the booth. Thank you.
Thank you very much, Stefan. And also thank you all for coming. I'm really happy to be here and take you through our data pipeline and how we built the Bitmovin Analytics product over the years. So jumping over, you probably have never heard of Bitmovin. Or has anyone heard of Bitmovin? No hands, OK. So that's good and bad. I wish you would hear of us. But we're actually a company from Austria, similar to CrateDB. And I'm from Austria, from Klagenfurt. And the Klagenfurt University is actually a university that's involved in the standardization of MPEG-, this streaming standard that basically the whole internet now uses. And our co-founders, two of them were actually PhD students doing their PhD and working on the standardization. And together with their professor, they then actually founded Bitmovin and decided to commercialize the standards work they've been doing. And so we are now an infrastructure provider. That's why you have never heard of us. We build tools like we have a distributed cloud encoder. We also have a video player, and we have the video analytics product. And these three things our customers then integrate into their application and build their video pipelines with it. And our customers are very big telcos and broadcast companies and stuff like that. So yeah, if you go to the website, there's a bunch of big logos that you probably have heard of, and you've probably all used some of our products somewhere without knowing about it. Yeah, and as you know, I mean, if you walk through the booths here, you probably heard a bunch of different versions of what analytics is. So I thought I'd maybe quickly define what we do. This is not about business analytics or the typical spreadsheet analytics where it's about, but it's really about visibility for our customers. So our customers use our tool to actually monitor and measure their performance of their video platform. So in essence, the video analytics tool, we have a collector that we ship, and our customers put that collector library into their apps or in their websites and use it to then, and the collector then reps to the player and figures out what the player is doing and generates telemetry from that. So every time you hit play in one of our players that's instrumented, we will generate between 50 and 100 records sensor data that we then ingest. And then in the end, it comes out as like you see here on the screenshot, we show you a graph. We show you a graph of what's happening on your platform. You see issues. You see if there's buffering, how long does it take to start the video, how many people are watching, and so on and so forth. So it's really about observability of your customers, for our customers, obviously. And now, if you look at this graph, I mean, the first thing every engineer probably thought, and I was when I joined Bitmovin, I was really excited about this because this looks like time series data, right? So I was like, yes, finally I can work with the time series database, and I can build a product that's super optimized around time series. And then I joined in 2016 as a senior software engineer, and they already had the product built because it took me a few months between the onboard before I started, actually. So they already had an MVP, and this was the first time I heard about CrateDB because I was asked, like, hey, we have the MVP ready. We tested it. We found out that this satisfies all of the requirements we had. So we have high ingest rates, as Stefan already said, but also we do return the queries very close to real time because that's a really important use case for observability. If something happens on your browser, your monitoring staff doesn't want to hear about it 10 minutes later. They want to have been fixing it for 10 minutes and have the problem fixed at the time. So we wanted sub-second latency of something happens and you already have it in your metrics. And then obviously, you also have a lot of data. Thinking about NFL games and these very, very big sporting events, you have to be able to scale. So they did a bunch of testing, and in the end, it won. And they had already chosen CrateDB when I joined. And I was then tasked with, hey, figure out how this works. Can we actually do all of the queries we want to do? And so I was like, oh, cool, this is SQL. I can just write SQL. And yeah, so I figured out, OK, how do you do time series from a row-based database, which was totally foreign to me at the time. For me, it was clear we need to have a time series database. But then I was like, OK, let's get on with it. And I was still not convinced that you want to have a SQL or a row-based database. But in the end, it was really like, OK, let's figure this out. It works. We get all the metrics out of it. And then we didn't have a product at that time. It was really like, we had started out, I thought I know what I'm building, but then you talk to customers, and the customers come like, yeah, we would have to like, we need this, we need that. And it turns out that we didn't really know when you start out as a startup, literally 2 engineers at the time on the product, and trying to figure out what you're building, you need to be really talking to customers and trying to see how they use the product, and then also being able to change that. And obviously, when you work in the time series world, you have to pre-aggregate stuff, and you have to generate all these metrics. And when you do that, it means you also have to maintain the data pipeline, and you have to actually work on making sure that all the data comes in real time and is available and stuff like that. So you have to do a lot of plumbing to get to the actual metric. And with a simple database, like in this case, with the approach we have with Crate, it was really like dump everything into the database and then figure out what the SQL query for that is. Still felt weird, but it turned out that we could really turn around customer requests on this in like weeks or days even. So customer tells you, at this football game, we couldn't see this one error, and you're like, yeah, I think we have the data already. Let me figure out if we can write a query for that, and then you add it to the dashboard and to the API, and everything works. So that was really where I thought, as an engineer, and I was really ready to build like the next time series database and rip out the core from Prometheus and use the Prometheus TSDB2 at the time to build our own product. It ended up being like, OK, let's focus on the product. And it turned out to be the perfect solution because we could just focus on actually building the UI and the value for that. And then it also meant that we have a database where there's a dedicated team that actually keeps working on the database. So we don't have to focus on the database ourselves. We focus on all the things around the database, on the customer use cases, on the video-specific stuff, and we're not in the business of building databases. And so one really exciting thing that we're actually going to roll out next week is we're getting, with 5.10 from Crate, we're getting a 55% storage saving, which is huge. I mean, the team is super excited about that, and especially, I'll give you some numbers later. Storage is the hugest cost factor for us. So they're just cutting by finding an optimization in the document engine, finding 50% of storage savings for us, which is cool. And so, yeah, that was the story there. How it looks like in our architecture, as you can see on the left side, we have the video player. The video player sends all of the telemetry data to the global load balancer. And then we load balance between our 2 redundant data centers, US and Europe. And what these ingest applications do is really nothing special. We just take the data, validate it, normalize it a little bit, but essentially every row that comes from the client goes into the Crate database, at a one-to-one mapping. And then on the other side, we have the customer using the dashboard. Dashboard then goes into the Bitmovin API queries, and we literally translate our query language to SQL queries in Crate. And the really cool thing here is that aside from the 2 redundant data centers, this architecture has been there for 9 years. We never changed that. It's really, it's so tempting to make it much harder and much more complicated. But we could just, and we still have the same architecture in place today, and we scaled from 0 customers to monitoring some of the very largest sports events that there are on the planet right now. So that's just how cool it is to have something like a flexible, seemingly not usable tool for what we're doing, but turns out that it's really useful in this case. And obviously, we did have to build a lot of stuff around this. So in the end, we built, we have an orchestrator, so whenever there's like a race coming up or a big sporting event, we have to scale the cluster for that. So we run our own, so CrateDB is open source. and we run it on our own EC2. So we have some tooling that will actually scale up the cluster, scale it down again afterwards. We also had to build some tooling for ourselves, like data migration, moving data between retention buckets and stuff like that, but also validate that we have tests in place that make sure that the stuff we collect is actually still the things, has the same shape of what we want to have. Yeah, and then also redundancy. So we found out kind of 5 years into the journey that if you ask a database, regardless of how good the database is, to do something very stupid, it will do exactly that. It will do something very stupid, and you will crash the database. So we had to actually figure out that our API allows customers to do very expensive queries, and very expensive queries that then take out the database, or cause it to be unresponsive. So we now have in our API, we have like a bunch of protections in there, high cardinality query protections, circuit breaking, fair load sharing, and so on and so forth. But still, in essence, it's still a very simple architecture. And then also over the years, and that was really the cool thing, it only took us like 6 or 7 years of growing the product until we actually came to the point where we have to optimize, where we have to really start like going into the details of what we're doing. Until that, we just dumped everything in there and was fine. We didn't hit any scalability issues, or it didn't matter so much what the cost was for adding more nodes. So you just add more nodes, it gets more flexible. But then 6, 7 years into the journey, we then also started optimizing. So we obviously know more about our data than the Crate database itself knows. So we know that we have immutable data. Yesterday's data is never changing, so we can actually aggressively cache the data and you reuse it. And we, in our query engine, we actually merge the real-time data that we get from today with the historic data that we had already, and we build our aggregation pipeline, so a custom aggregation pipeline on top of the Crate aggregation pipeline. And also one more thing, which is a general thing, any database you use, you have to talk to database people at a certain scale. So with, at this point, the time where we are with the scale that we handle, we need the Crate support pretty much for every new feature we do, just to talk about how stuff actually ends up on disk. Like, how is the indexing engine going to write this segment to disk? How will this index be hit? How's the memory performance of these new functions, and so on and so forth, and also the shape of our data. Because that's very specific, and if you're, like we do, ingest something like 160,000 inserts per second, you really need to know where it is on disk, and especially if you read it afterwards, you need to know how the database will behave. And this is what we use Crate support extensively for. So these are the numbers. We do 15,000 inserts per second as a base load, and that is not base load like now. That means 4 o'clock in the morning where no one watches video. That's our quietest time. And then during peak, and peak means the prime time for us. So that's not that's sustained peak. 160,000 requests per second going to the database for like 2 or 3 hours during prime time. It goes up to 200K, sometimes more. And then we currently store 96 billion rows in the Crate database. And if we need more storage, we just add more nodes. The 96 is also only 30 days of data, so a mix between the 30 and the 90-day retention data. And it's like 1.5 terabytes. And I highlighted this here, the 25 to 100 queries per second. That's also, while we're writing all of this data, we're also querying it all the time. So we have an API, and the customers really integrate with that API. So a lot of them have built their own monitoring stuff on top of that, and some downstream processing things. So alerting, it took us 9 years to actually build our own alerting pipeline. So customers already built it on the API. And so that means that while we're ingesting all the data, the customers are also fetching the data all the time, which is really, really cool. Yeah, and all the queries return data in real time. So it's currently the end-to-end latency of you hitting the play button until we actually see it in the graph is 5 to 10 seconds. So with all of the indexing and so on and so forth in the database, but also with the batching we do on our application. It's really cool. Yeah, and with that, I'm actually much faster than I expected. I will leave you with a little bit of a summary, which is our journey really was about, I wanted to like really hard prematurely optimize the product. I thought I know what we're going to build. I thought I really know the problem. I thought it's going to be easy. Let's build a database. And I would have loved to do that. It's really an interesting challenge as an engineer. But as Donald Knuth already said, premature optimization is the root of all evil. And in this case, we would have failed totally. Our CEO and our CTO at the time really, I was always driving this home, is like, do things that don't scale. And we turned out to pick a technology that actually scaled with us, so we still have the same technology, and over years, we still run the same size cluster. Like for the baseload stuff, we still run the same size of cluster we did 10 years ago. It's just that the product and the CPUs and the EC2 stuff got so much faster that we can still scale within the same thing. But what we did was we focused for 6 or 7 years really on scaling the product, scaling the business, and getting bigger, and having a database that just fixes the tech stuff underneath. So we really didn't have to focus on building a very, very efficient aggregation engine that can do metric calculation in real time. We could just write queries, and SQL queries at that, which means that all the new engineers onboarding, for them it's super easy. Hey, it's SQL, and you just need to tell them, don't use the nullable stuff, because that's a little bit less efficient than the normal stuff, because of how Crate internally indexes stuff. Yeah, so that really helped us, and it was a key driver for the product to be flexible and to tell customers, that's a good idea, let's build that. And a week later, you come back, we built that. And then you have a very, very big telco company, and they're like, yeah, everything we want built in-house takes 6 months. And you built in a week. Cool, let's try this. That's really, really key if you're a startup. So yeah, highly suggest that. Yeah, and with that, you can also, so I didn't include a demo of the product, but if you want to see the product, come by the booth. The Crate folks will also tell you gladly about CrateDB. There it's booth C65. And yeah, thank you very much for your attention.